Okay, so hello everyone, welcome. Okay, so can you hear me? Okay, so just we're waiting 1 or 2 minutes for joining all of those other participants, then we'll start. Okay, so now we'll start today's session. Okay, so basically today I will try to discuss about that change detection analysis using Google Earth Engine platform. So different types of change detection analysis such as land use, land cover change detection between the two time period, NDVI change detection between the two time period or 2 decade. Okay, so how we can easily do that using Google Earth Engine platform, as well as how we can easily use the calculate the hyperparameter tuning to develop the machine learning algorithm accuracy. Okay, so let's go. Just I simply share my screen. Okay, so now can you see my screen?
Yes.
Okay, so let's go. Okay, so basically today I will try to discuss about this part, mainly land use, land cover change detection using Google Earth Engine. Then NDVI change detection using Google Earth Engine. Then class-wise land use, land cover change detection in one layer using Google Earth Engine. And also hyperparameter tuning for improving the accuracy of our machine learning model. Okay, so we'll start from the hyperparameter tuning and then one by one it will discuss. So let's go. So previous class, we also try to make the land use land cover classification map using land sentinel imagery. Okay, so previous class we try to make this land use land cover classification. And we are just use here a algorithm, mainly random forest. Okay, so here you can see we are used here the random forest algorithm to make this classification model, and we are put here the number of decision trees. This value is the 150. Okay, but in this time we don't know what's the best value for this model. Okay, and this best value called the hyperparameter turning. Okay, so in this time we are just use a function and then calculate the hyperparameter turning. So mainly hyperparameter turning, this value provide you the best accuracy of this land use land cover classification map. Suppose this value we can easily calculate from here, and then we can simply put here this value, then we are just make the classification hyperparameter turning. So in this time I don't know what's the value for that. I randomly put here the 150 and I make this algorithm. Okay, but in this time, first of all, I just make or calculate or find out the hyperparameter turning. Okay, so for that, okay, so I just simply run this code in here. Okay, so I start from here. So from here, so in this time I just find out the hyperparameter turning. What is the value for this for my model, and this value when I use, then I can get the best accuracy. Hyperparameter turning. So in this time, I just make a number of trees list. Actually, it's a number of trees list. And in this time, I just make a sequence. Suppose I just put the value 10 to 200 and put the interval, suppose 10. And it will be checked for each number. Suppose 10, 20, 30, 40, 60, 70, up to 200. All of those values check and also provide the accuracy. Suppose I just make a list. So for that I simply put a variable, suppose a number tree list, and then make a list. So use our art engine list sequence. So in this time, this function I put, and I want to start the number of trees from 10 and up to suppose 250. Okay, and in this time I put the interval level, suppose 20. Okay, so in this time number of trees will be start from the 10, and then an in value will be 250, an interval, every interval 20. So I can get the value, suppose 10, then 30, then 50, then 70. Okay, so this type of value I can get from here. Suppose when I put here the 30, then I put the value 10, then I can get the value 40, then I can put the value 70. Okay, so this interval will be 30. Or if you want, you can put here the suppose 200 and put here the 10. So it will be start from the 10, then 20, then 30, then 40, then 50, 60, 80, and up to 200. Interval is the 10. Okay, so in this time we are just making number of tree list, and here I put here the list value will be start from the 10 and up to 200, and every step interval is the 10. Okay, so now between this value I want to check what's the accuracy I can get for this model. So in this time I put all of those value. Okay, and check my accuracy. What is the accuracy I can get when I put here the 10? Suppose I put here the 10, what's the accuracy? When I put here the suppose 20, what's the accuracy? Put the 30, what's the accuracy? Put the 40, what's the accuracy? And up to 200, what's the accuracy I can get? Okay, so in this time we are just use a function, and using this function we can easily do it very easily, and from this we can easily identify what is the best value for this model. When I put this value, then I can get the better accuracy. Okay, so let's go. So in this time I just make a function. So for that function I just make a variable. First of all I take a variable. Suppose I put the variable name is that accuracies, and then I just make a function. So just make a function. I put the element name. Suppose I put the element name is that number, or put here the Any name. Suppose I put here the number, Chris. You can put any name. So now I just make a curly bracket and put my argument. In this time, I just calculated the train my model and also check about the accuracy. So just I simply take a variable, suppose classifier, and then ee dot classifier dot smile random forest random, f is uppercase, okay, random forest. And in this time I did not put any value, okay. I simply copy this element name and paste here, okay. So it means that this value come here 10 to 20, 30, 40 up to 200 and check one accuracy. Suppose when I put here the 10, what's the accuracy? When I put here the 20, what's the accuracy? When I put here the 30, what's the accuracy? It check one by one, it check, okay. So just I put put this element name, number of trees, and then I use it and train my model. So just use here the train my model. So in this time we are just simply put all of those argument for train my model. So just make a curly bracket start and also curly bracket end, okay. So first of all, here you can see the feature. So in this time we are just using the 80% data which I already make in a variable. So just I simply copy the train set and paste here. Then put the class property. I already make the class property. Class property mainly is your property name. So this property name is the class, and input properties mainly in this time our all of those band pixel value. So which is stored in this variable bands. In this time, not nice remove that. It's simply remove that. It's not need. Okay. So now I just train my model. Okay. And then I return from here the accuracy. So just use here the return this accuracy. In this time, I want to find out the accuracy from my test set. Okay. So I already make the test set in here. You can see test set. I simply copy this variable test set and paste here. It's done. So now I simply add with my model. So just use add the classify with my model. So my model name is that classifier. So just I simply copy and put here. Okay. And from that I simply calculated the error matrix. So just use add the error matrix and put here the actual value mainly class, and predicted value simply put here that classification. Okay. And then finally I simply make here the accuracy. Okay. In this time what happened, you can see in this function we are not put any types of specific value. Okay. We are just make the number of list which is including the 10 up to 200, and interval is the 10. So I can put here the 10, 20, 30, 40, 60, 70, 80 up to 200. I simply copy this variable name and paste here for connecting these things using the map function. So just put here the parenthesis and also put here the parenthesis. So now it's connecting. Okay. So now it's connecting. If you simply print that, suppose I print these things, accuracies, simply print and click the run. In this time you can see what happened. I can got. Okay, just make a notation. Suppose it's a accuracy. Then we can easily find out it. You can see as the least we can get this result. Okay, we can get the 20. Okay, here you can say I can get the value look like that. So here I can get the suppose 92, 90, then 91. It also better when I make a chart, then we can easily identify about that. So in this time I just make a chart. Okay, and from this chart we can easily get this accuracy. So just I take a variable chart, and then I use at the UI dot chart dot array values. Okay, and put all of those argument one by one. So just make a curly bracket stat and also curly bracket in here. So first of all, array. So mainly this array is our accuracy. So which is stored in its variable. So you put at the ee dot array and call this accuracies and paste here. Then axis, I simply put here the axis. Okay, in this time put here the 0 and x level. So mainly x level identify about that number of trees. Okay, so number of trees which is including the from 10 to 200. Simply copy and paste. So now simply print the chart and click to run. So now it's working, and create the another chart. Get the chart. Okay, so here you can say I can get this type of value. Suppose you can see when I put at the 10, I can get the 91%. When I put at the 20, I can get the 91%. Also, you can 30, 91%, same. So all of those decision number trees, when you want to put, we can get the accuracy is the 91%. Okay, and you can see also see here the another thing is that when I put at the 150, I can get the 92%. When I put at the 160, I can put the 92%, same. 170 same, or you can see 180 same. So 190 same. You can see 200 same. Okay, or if you want, suppose you want to increase the range, so just you try to use at the suppose 250 or put at the 300. Okay, okay, then click the run again. Then this time it also start from the 10 and check up to 300 and also make the accuracy. So you can see. Okay, so I think this model is better. You can see 210, we get 92. Okay, so all of those things you can get the 92. So from here, when you want to use it, this value 140, I can get the 91%. So this type of value, this type of number of decision tree provide me the 91%. And when I put this type of value, then I can get the 92%. So from here you can choose anyone. Suppose you can to 220 or anyone. You can simply select and put your model. Suppose you can simply put your model. Suppose you can say here I already use here the 150, so I can get a 91%. So suppose when I put here this 180 or 90, I can get the same value, 92%. And we already calculate the accuracy. You can see I can get the 92%. So suppose in this time I just simply put here the 250. Suppose I put here the 250, I can get the same accuracy also. 250, I can get the same accuracy about that. So here you can see we get the same accuracy, 92%. Okay, so all of those value when you want to use, we can get the 92%. And when you use this type of value, then we can get the 91%. So for my model, I use suppose this type of value, and this type of value called the hyperparameter tuning. Okay, and this is the process to find out for your model what value you want to put in here. So in this time I check from here any value I can simply put in here. All time I can get the same accuracy. Okay, but when I put this type of value, then it also low, 91% I can get from here for this model. So this is the process to identify hyperparameter tuning and use the value in here, and then this map also get the better accuracy.
So can you explain it again? Sorry.
Okay, I can explain. So in this time, hyperparameter tuning. So hyperparameter tuning, this value, suppose in this time when I put here the 150, suppose you can say 10 or this type of value, suppose 90 or to 130, then I can put the low accuracy, mainly 91%. I can get the 91% accuracy. Okay, but when I use this type of value, then I can get the 92% accuracy. So it also increase. So in this time for my model, when I put this type of number of trees value, then I can get the 92% accuracy. So this type of value called the hyperparameter tuning. And when I put this type of value, it's also low accuracy. So it's not my hyperparameter tuning. Hyperparameter tuning, this term is that which value is the suitable, best value for your model. When you use this value, you can get the better accuracy. Okay. So in this time, when I use this type of value for my model, then I can get the better accuracy. So just I use anyone from here, and this my hyperparameter tuning. And how I can find out? So for that, this technique we are just using here. Okay. So first of all, you just make a list about your number of trees. Okay. And then just make a function. And then in this function, we are just make the algorithm. And we are check for all of values, all of number of trees. What is the accuracy I can get from here? All of values is just calculate from here. Okay. All of values. So it will be start from the 10 to 300. All of those value considered in this time. And in this time, we check it when I use this type of value, suppose 10, 20, and then I can get the 91%. But when I use this type of value for as the number of trees, 150, I can get the 92%. Also, in the 160, I can get a 92%. Also, you can see the 190, I can get the 92%. So this type of value is the hyperparameter tuning. Suppose actually, what is the best accuracy? Which value give me the best accuracy? It's my hyperparameter tuning. And I can easily find out from the chart. Okay. So this value when you put in your model, then you can get the better accuracy. Okay. So any question about that? You can ask. Okay. So it's the same process you can also apply. Suppose you can use the same code for other parameter for finding the hyperparameter tuning. So first of all, when you run your model, we are just make a any value. Okay. But further, when you want to find out your best value, best number of trees, it's called the hyperparameter tuning. You have to find out from here. And then you are simply put in this here and then export this map. Then you can get the better accuracy. Okay. Okay, I hope it's clear. Or any doubt? Okay. So basically, this is the process to find out the hyperparameter tuning value to find out the best number of trees, which values give me the best accuracy for this model. Okay, so I'll send you the code. You also try to practice. Okay, as well as in this time, we also try to discuss about that land use land cover classification. Okay, we already discussed about that. In this time, change detection. So for the change detection, I already set an example in here. So in this time, here I already make a map for land use land cover classification map for the 2 time period. Okay, suppose mainly it show about the year of 2021 and 1981. Okay, so in this time I just make the change detection between the 2 decade land use land cover classification map. And for creating the land use land cover classification is the same process we are applying. Okay, so here I show you the previous class. So in this time we just make the 2 land use land cover classification maps. One is the 2021, another is the 1981. So now we are just make the change detection as well as also make the transition area, calculate the transition class. Okay, how much water will be convert into the vegetation or how much barren land convert into the build-up area. So you can see this is the map 2021 and this map is 1981. Okay, we can get the 2 time period map. So basically in this time red color identify about the build-up area or settlement, and then this green color identify about the vegetation or forest, and yellow is the mainly barren land. It's the water body. Okay, so now we are just make the change detection between the 2 map and then calculated the transition area. Okay, and in this time you can see first of all we are just take the image for 2021 and also take the image for 1981. Okay, and now same process we are applying for the supervised classification. First of all, we just take the training sample, just open the 1981 image and then collect the training sample for water body as well as also build up as well vegetation and also others mainly barren land. We take this training sample. Okay, after that we are just make the land use land cover classification map, and we are just for after doing that we are just open the 2021 this satellite image, and then take the same process for taking the water body, then build up, then vegetation, then others. Just take the training sample for image 2021. Okay, so further we are just make the classification and make the 2 decade land use land cover classification map 1991 and 2021. Okay, so which is represented here 2021 and 1991. So now we are just make the change detection and calculated the change area for each classes, as well as also calculated the transition area, how much water body convert into the vegetation, or how much barren land convert into the build up area. So this type of calculation in this time we try to discuss one by one. Okay, so before that, first of all we try to discuss about the single class map. Okay, suppose year of 2021 I want to make the single class or single class change detection. I want to focus only for the build up area or settlement. Okay, so this type of rate to identify about the build up. So in this time, I just only focus the build up and try to find out the change detection of build up map or single class change detection. Okay, so let's go about that. So this is the code for that making the land use land cover classification map. In this time, we are using at the Landsat image because 1991 we must use at the Landsat image for the historical analysis. Okay, so now just okay, so in this time I just simply show the code and explain one by one, it also better. So first of all we discuss about the suppose single class urban or build up area, calculate how much urban area in year of 2021, how much urban area is available, I want to calculate it. So for that, first of all I need to make a single class map. Okay, so for that, first of all I simply take a variable, you can put any variable. So I put a variable name, suppose build up area 2021. Okay, and call my classified image for 2021. This variable mainly stored this map 2021. This map is stored in this variable. Okay, so you can check it from here easily. You can see you can see layer name. Okay, so you can see the two layer. One is the LULC 1991. LULC 1991 is stored in this variable classified RF 1991, and LULC 2021 it is stored in the classified RF 2021. Okay, it is stored in here. So I simply copy this variable. Okay, classified this because it is stored the full land use land cover classification map. So I simply call and then simply set here equal to 1. Okay, so in this time what is the 1? 1 is mainly my class number. Suppose you can see 2021 and check the value about that. I set the value for 1. Okay, so value for 1 it means that it's a build up area or settlement. Okay, because I set the value as the 1. So now I just make the map layer. So for that I simply call the map.add layer function and simply copy this variable name, and I put here the 0 and 1. And 0 mainly there is no urban, 1 means urban is present. So I want to show the color gray color where there is no urban, and put here the red color where there is urban is present, and give a layer name urban 2021. So now let's check about this layer. So now it's created another layer, you can see for urban map 2021. Okay, so here you can see now this type of gray color identify about that there is no urban, and this type of red color identify about that urban or build up or settlement area for this study area in year of 2021. So this is the process for making the single class map. Suppose you want to make the map for water body in year of 2021. So for that, first of all, you need to check about the what is the value of water. You can see it's mainly 0. So 0, water 0. So I simply put here the 0. Okay, 0 mainly value of water. I want to show the water body as a suppose blue color. So just put here the blue. So now it display the result of water body map in year of 2021. Okay, so now it's loaded.
Sir, did you use the same method for the calculation, like for the calculation of like
Yes.
you taught us yesterday?
Okay, we also try to discuss about the calculation. No problem. Okay. So in this time, you can say I can make only for the water body map. Okay, you can see this place is only for the water year of 2021. So in this time, I want to calculate how much area is available for that urban. So I need to select the urban value. Urban value is the one. Select the one. Okay, and I need to show the urban as a red color. So red. So now I can get the urban map. So further, I want to calculate what's the area of urban in year of 2021. Okay. Previous class we discussed about the chart method. Mainly we try to make a bar column chart and then calculate each class's area. But in this time we are not talk about that because chart is not capable when you want to work with for the big region. Then we face some problem for creation of chart. In this time we are just talk about the another method. We are directly use here the function. This function called the image.pixel area. This function. Okay, we need to use. So basically, it's calculated the area in square meter, this function. So I simply call the build of area 2021, this variable, and multiply with my function. This function calculates the pixel area in square meter. So just multiply. Then further we use it, the reduced region function you have to use. So for that, we use here the urban area. Take a variable. You can put any variable name. So just call the urban area and put here the reduce region function. Okay, so further we are just put here the reducer. In this time I calculate the total area, so use here the sum, e reducer the sum, then mention about your boundary. So this is your boundary shape file AOI. Okay, and further we are just use here the scale mainly is your resolution of your satellite image. In this time I use here the Landsat, so use here the 30-meter resolution. So further when I print that, then I can get the result of urban area in year of 2021. So now let's check. Click the run. So now here you can see we can calculate the urban area. Where is it? Okay, this here you can see object. So here you can get the total urban area. It show the result in square meter. So we can easily convert into square kilometer. So for that we are just write the code. I simply take a variable, suppose urban area square kilometer in 2021, and it's a number. Okay, so that's why we have to use here the EE dot number, and this number is stored in a variable, this variable, and you can see it's get from the classification. You can see classification, same things we have just put in here classification, and divide with 1 is 6, mainly 1 into 10 to the power 6. When you want to divide with that, we get the result in square kilometer. Okay, so further I simply print this result from here. So now click the run. In this time it calculated the area in square kilometer. So here you can see computing this area year of 2021. What's the urban area we can got? We got 74 square kilometer area. Or if you need only in this time it also show about the some floating number. Suppose you need only for the integer value, just put here a function. This function called the round function. So mainly this function provide you the round figure only for the integer value. So here you can see it calculate. Here again 75 square kilometer. Okay. So now we can get this result for urban area in year of 2021. For this area, we can get the 75 in year of 2021. So let's do the same things for that year of 1991. Okay. So in this time, we are just do for the same things which I do for the year of 2021. Same things also do for that land use land cover map 1991. Same approach. And calculate the area of urban in 1991. Okay. So just in this time for 1991, what is the condition for the build up area? Same process. Just take a variable and then simply call your classified image of 1991. Okay. Here you can see it show this variable look like that. You can see classified image. Okay. This variable is stored the classified image of 1991. Okay. We can get. So simply copy this variable and paste here, then set equal to 1. 1 mainly, what is the 1? 1 is the build up area. Okay, you can see build up area value is the 1. So just put here the 1 and simply set about the map.add layer function. So in this time I show about the urban area, urban 1991. So now click the run. So now it calculate.
Sir,
Yeah, please.
is it possible to make a iteration that can calculate for each classes in of each year's the value of the area?
Yes. So I go to further. So first of all, I discuss about the single class. Okay, then we talk about the multiple
Okay.
class. So in this time, I talk about only for the single class. Mainly, suppose sometimes it's very need for the urban development. This type of things we need, or urban spiral.
Mhm.
This type of things. The single class we also need. But for the single class, we are just use. Suppose in this time, I consider for the urban. But same process you can also apply for the other classes also for the single class. After doing that, we are just talk
Okay.
about the multiple class at the same time. What is the condition we discuss? Okay. Okay. So in
Okay.
this time, here you can see it create the two map. One is the urban. So mainly urban map in 1991. So it display the map for 1991. So you can get this map. And we are also get this map for 2021. You can see. So lot of urban increased between the 1991 to 2021. This time period, you can see urban area increased. We can get from here. Okay. So now if you want, you can also calculate it the area. Suppose how much area will be increased, we can calculate. Okay, first time only for this urban or build up, but you can see this 2021 it showed a lot of build up area will be increased. So urban development. So in this time we calculated the area. So for doing the area, same process just apply. Just take a variable and then simply use the same function for reduce region and calculated the total area, okay, which I show for the 2021. Same process we try to apply and then calculated the area and print the area. And I also need the print the area for a square kilometer. Same approach is just apply and then just print this. Suppose I need the round figure, so simply use at the round function, get the round figure, click to the run. So now it's also calculated the area for year of 1991. So here you can see 5. Okay. So in year of 1991, we got this area of urban only for 5 square kilometer. But in this time, we can get the total area 75. So how much area will be increased? 70 square kilometer area increased. You can see. So it's only for that 5 square kilometer. Okay. But we can get the total urban area in 2021, which is the 75 square kilometer. So how much increase? 70 square kilometer area increased. In this time, I want to show for the change detection. Suppose between the two maps, suppose urban 1981 and 2021, I want to show the change detection. Okay. Suppose urban area, you can see it's the urban, it show the urban area. And year of 2021, we are also get the urban area. So there is no change only for this. Suppose this portion you can see. Suppose these things, this type of urban is available for 1981 and 2021 is also available, this type of urban. So for this, there is no change. But other region, you can see this type of region where there is no urban, but in 2021, we can get this lot of urban area. But okay, so now let's check about the change detection. Suppose this region, there is no change. It's still for the 1981, we got the urban, and 2021, we also get the urban. There is no change. Okay, but also increase the urban. Okay, urban sprawl you can find out from here. So in this time, I make the change detection. So let's go how we can do that. For doing the change detection, just take a variable. Suppose urban changed. Okay, then simply put here the 2021 build up area, subtract with 1991. Okay, so in this time, first of all, you can get the suppose present and it's a past. Suppose it's a before and after. Okay, so simply subtract two things. So 2021 subtract with 1991. Suppose 75 subtract with 5, then we can get the 70. Okay, square kilometer. In this time, we are do for the same things. In this time, suppose first of all, we call about the build up area 2021. So in this time, it's the after and it's the before. You just simply subtract these two things and then make the change. Okay, in this time, here I put here the urban changed. I simply copy this and paste here. And suppose in this time I put here the suppose yellow color. So this yellow color identify there is no change, and red color identify about the changed. Okay, so yellow color identified there is no change of urban, and red color identify about the change of urban. So now click the run. So now we can get the new layer. Okay, and here we can find out the yellow color which identify there is no change. Suppose past time 1991 we got the urban, and present time is also urban. Okay, so there is no change. It loaded. Okay, you can see. Okay, so this type of color, suppose this type of yellow color identify about the there is no change. Okay, only for the urban, because in this time we talk about the only for the single class for urban. So in this time, this type of yellow color identify there is no change. Okay, and this type of red color identify about the changed area. Okay, for the urban, and how much area increased about in this time? Total 75 square kilometer area we can get as a new urban area in year of 2021. It increased. Okay, so in this time it represented, you can see it also show about the yellow color in this time, because there is no change, because you can see from this map we can get the urban in this time. Okay, in 1991, so there is no change, and 2021 we also get the also urban in here. So it means that for this region there is no change. So that's why in my final map, when I create the change detection, it also show about the yellow color, because yellow color identifies that there is no changed area. But this type of area will be changed. Suppose it will be barren land, but now it show about the build up area. So this type of change we can find out from here. And how much area will increase in this time, we can get the 70. Okay, so if you want to calculate the area from this map, we can get the red pixel value. This total area is the 70 square kilometer. Okay, because 5 square kilometer is already available, there is no change. Okay, so it's the urban, and present time is also urban, so there is no change in this time. From this type of red color, total area is the 70 square kilometer. Okay, so this is the process for the single class change detection, and you can easily download this type of map from here, and you can also make the map using ArcMap software for your research paper preparation. Okay, so this is the process for the single class change detection. So any question in here, you can ask me. Any question? What that single class change detection? Okay. Okay, so in this time we talk about that suppose multi-class. Okay, at the same time, all of those class I want to make the change detection. For the when you want to do for the multiple class change detection at the same time, we have to apply some formula, or we have to apply some method. So in this time, first method, we need to reclassify. So how I can reclassify? Okay, so for the reclassify, in this time here you can see we put at the 0, then 1, then 2 and 3. Okay, also 0, then 1, 1, then 2 and 3. Okay, so in this time, this type of value I need to reclassify. Okay, this is my first condition. I need to reclassify. So 0 to 3, I reclassify 1 to 4. Okay, suppose you can see, I show you the code. Suppose first step, you need to make the reclassify. Suppose 0 to 3, it's already available. It will be start from the 0, then 1, then 2 and 3. So now this 0 to 3, I simply reclassify into 1 to 4. Okay, so now 0 water will be 1, build up 2, vegetation 3, others 4. Okay, when I do that reclassify, this 0 convert into 1, then 2, 3 and 4. So for the reclassify, what can I do? Just take a variable before class. So mainly in this time 1991, I simply call this map LULC map 1991, I simply call and use as the remap function. So mainly this remap function we are used for the reclassify. Suppose in this time this value 0, 1, 2, 3, I simply put at the 0, 1, 2, 3, and now I convert his value. I want to convert 1, 2, 3, 4. So now 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. Okay, so it's the reclassify. So same process we are also do for the after class, which is mainly 2021. So just I simply put the classified RF and remap. So in this time we are just put here the remap function for reclassify 0, 1, 2, 3 to 1, 2, 3, 4. Okay, so now 1 is water body, 2 is build up area, 3 is vegetation, 4 is barren land or others. We are just simply reclassify. So it is a main condition, first step. Okay, after doing the reclassify, we are just use the formula. Okay, so in this time, first of all, we are just make the changed. Okay, so mainly changed in this time, we show this type of way. Suppose in this time I'll just take a variable, and then after class, mainly 2021, after class, subtract with before class, and not equal to 0. Okay, so in this time we are not considering the suppose same class. So when I can get the same class, it not equal, we set it. Suppose water, suppose I can get the water, and 2021 I also get the water, so there is no change. So this type of things we are just put at the not equal to 0. And now I'll just make the show the layer about that, and here we can show the result white and red. So white color identify there is no change, and red color identify about the change. And this is the show for overall change, not only for the single class. Suppose it show the overall change. Suppose where I find out the white color, it means that there is no change, and when I find out the red color, it means that there is changed area. But which class is changed? Okay, so further we also write the another code. In this time it show about the overall changed. Suppose changed and unchanged area, we are just make this classification overall changed for all of classes.